Welcome to the Unit 6, Section 6 video on applications for systems of equations. So in this section, we are going to solve real-world applications, but before we get there, let's talk about the different methods that we have done in this unit, because when you get into solving these word problems, you're going to have to figure out which method is the best one to use to solve with. So let's look at this table and let's figure out which method is best in different situations. So when you are looking at graphing is going to be best when both equations are solved for y, because you've already got your slope and your y-intercept laid out for you. It's also good when you want to estimate a solution, or if you know for sure that your solution is going to result in integers or whole numbers. Because if you don't have whole numbers, the best you're going to be able to do is estimate your solution. Now, substitution is going to be good if you have a variable in either equation with a coefficient of 1, because you can easily solve for that one variable that's isolated, that's by itself, and then you can substitute it into the other. So this may be that both equations are solved for the same variable, or either equation is solved for a variable. And then elimination is good when both equations have the same variable with the same or opposite coefficients. So in this top example with elimination, you have a 2y in the first one and a 2y in the second one. It's also good if you can multiply one of your equations to create that situation. So in the second example, you have 6x in the top one. You can multiply the bottom equation by 2 to turn 3x into 6x. So it depends on the situation you're in as to which method is going to be best for you to solve your problem. So let's talk about solving word problems. To solve a word problem, follow these 3 basic steps. Define your variables based on your unknown quantities. Oftentimes, this is going to be asked of you at the end of the word problem. Write your equations based on the information given to you in the problem, and then solve using any method. So we just went over the 3 methods. Figure out which method is best for you to solve the problem. So let's take a look at example 1. The sum of 2 numbers is 42. Their difference is 6. Find the numbers. So the 2 numbers that we're looking for are our 2 unknown quantities. So let's define those. One number is going to be bigger than the other. So let's say x is the greater number, and let's say y is the lesser number. Now we're going to translate the information in this word problem into equations. So let's start with the sum of 2 numbers is 42. If we're talking about the sum of 2 numbers, we're adding them together. One number is x, the other number is y. So we are simply saying x plus y equals 42. The other sentence says their difference is 6. So the difference of the 2 numbers is 6. That means we are subtracting them. And since it's a positive number, we have to take the greater number and subtract the lesser number. So our greater number is x, our lesser number is y, so we will do x minus y equals 6. Now that we have our two equations with our 2 unknowns, we are going to solve this system. Since we have a positive y and a negative y, I think elimination may be our best method. So let's stack our equations, and let's add the 2 equations together. When we do this, we eliminate the y's. X plus x gives us 2x. 42 plus 6 gives us 48. Divide each side by 2, and you get x equals 24. Now that we have x, let's substitute it into one of the 2 original equations. So let's just take the first one, put 24 in place of x, subtract 24 from each side, and we get y equals 18. So our 2 numbers are 24 and 18. Remember, a word problem requires a word answer. Does not have to be a long word answer, just enough to give us what the context is. All right, example 2. Yuri is twice as old as Zach. 4 years from now, the sum of their ages will be 23. How old is Yuri? So let's, first of all, to find our variables. They're asking how old is Yuri, so let's let x be Yuri's age. X is what we're going to be looking for. Well, we also need to know Zach's age because we're talking about Yuri's age in terms of Zach's age in this problem. So let's let y equal Zach's age. Now, let's create our equations. Yuri is twice as old as Zach. So if Yuri is twice as old as Zach, we have to take Zach's age and double it to get Yuri's age. Or in other words, multiply Zach's age by 2. So 2y equals x, or x equals 2y. 4 years from now, their sum of their ages will be 23. So, what does this mean? Well, in 4 years, Yuri will be x plus 4 years old. In 4 years, Zach will be y plus 4 years old. And if you add those two things together, it will be 23. So x plus 4 plus y plus 4 equals 23. Now we've got our two equations. Let's work with them. And I believe substitution will be a good method to use because we have x equals to something. Okay? So since x equals 2y, we're going to put 2y in place of x. But before we do that, let's clean up that second equation a little bit. Let's combine our 4's, combine like terms. So we got x plus y plus 8 equals 23. And let's subtract 8 from each side. That gives us x plus y equals 15. Now let's substitute in our 2y for x and combine our like terms. So that gives us 3y. And then divide each side by 3. So y equals 5. Now that we have that y equals 5, let's go back to our first equation, substitute that in for y, and then multiply. 2 times 5 is 10, so x equals 10. So that's what we were looking for. Since x equals 10, Yuri is 10 years old. That's all we were asked for, so that's the only answer you need to give here. By the way, since y was 5, that happens to be Zach's age. Example 3. Jennifer's school is selling tickets to a play. On the first day of ticket sales, the school sold 3 senior citizen tickets and 12 child tickets for a total of $84. The school took in $76 on the second day by selling 10 senior citizen tickets and 6 child tickets. What is the price each of 1 senior citizen ticket and 1 child ticket? So let's start off by defining our variables. That's in our last sentence, or our question. What is the price of 1 senior citizen ticket? So let's let x be the senior citizen ticket price. And 1 child ticket. Let's let that be y. Now in the second sentence, it says on the first day of ticket sales, the school sold 3 senior citizen tickets. So we made $3x in senior citizen ticket sales. So that's 3x plus 12 child tickets, so that's 12y, for a total of $84. So 3x plus 12y equals 84. In the second sentence, we sold 10 senior citizen tickets, so that's 10x, 6 child tickets plus 6y, equal to the total of $76. So now we have our two equations with our two unknowns. I think elimination will be a good method to use here, because if we multiply the second equation by 2, then we will have a 12y in the first equation and a 12y in the second equation. So we'll multiply the second equation by 2 and solve by elimination. We leave the first equation alone. We multiply the second equation by 2. So 10x times 2 is 20x, 6y times 2 is 12y, and 76 times 2 is 152. And we will subtract these two to get the 12y's to eliminate. So 3x minus 20x gives us negative 17x. 84 minus 152 gives us negative 68. And then if we divide each side by negative 17, use your calculator if you need to, you get x equals 4. So now that we have x equals 4, we're going to substitute that back into one of the equations. So let's just use the first one. Put 4 in place of x. 3 times 4 is 12. Then we subtract 12 from each side, so 84 minus 12 gives us 72. And then divide each side by 12, and y equals 6. So now, it is important to use a word answer, because If your question is, what is the price each of one senior citizen ticket and one child ticket? And your answer is X equals 4, Y equals 6. That does not make sense. It does not answer the question. X equals 4, great. What does that mean? I have no idea what that means. For what? What is X? Okay, so you've got to put it in terms of what you're being asked of. You have to give a word answer. So our word answer here will be that senior citizen tickets cost $4 each and child tickets cost $6 each, because X is 4, and that's what we designated as the senior citizen ticket price, and Y is 6, which is the child ticket price. So $6 for a child ticket. All right, this concludes this unit on systems of equations.